afternoon, good morning, everyone. My name is Nadia Sid, as Rochelle mentioned it. And today we are here to go over the new feature, improvement, and all the excited newness, I like to call it, in Maple 2024. So by now, I hope that all the participants and most of you would have already purchased, download, upgraded your Maple to have access to Maple 2024. And what I'm going to do in this session is to show you like a bit of a mix of what we've been doing in Maple 2024, both from a new features perspective, but also improvement of some existing command. And all of that, of course, as you all know, for those who know Maplesoft and who know us, we always take into account the feedback of our user. So whether it is to build a new functionality within the product or fix a bug or improve a functionality, please be aware that like this is really important for us. So like I'm going to present some of those. There is, of course, many more, but any feedback or any comment is always more than welcome, actually, on the product. So without further ado, let's start. I didn't know with which part I was going to start, but I thought that I would start with the most exciting one, actually. And this is the new feature that include the link between Maple and artificial intelligence. I can open my worksheet. So let me zoom a little bit. So as I think most of you by now, I hope, know or would have heard of, artificial intelligence is now a hot topic. So we've heard a lot from both teacher, researcher, and user about this, asking like if they could actually access some of those via Maple instead of like switching platform or something like that. So what we've been doing is implementing two types of interface to allow that. So I'm going to start by the first functionality, that is the Maple AI Assistant Formula. So the Maple AI Assistant Formula is an assistant that is going to help the user, whether it's student or any other type of user, to access specific equation. So to access it, you need to open the left panel that is on your Maple interface, just here. And for those of you who are familiar with Maple, so you're going to have access to the palette workbook tab also. But you can see that now we have a new tab that is called AI Formula Assistant. So once you open this new tab, you have the possibility to ask to the AI, so that is connected to the Maple server, to return any type of equation. So to illustrate that, I decided to pick up two types of examples just to show a bit how this functionality could be used. So the first example is this exercise. So I'm in a case where I could be a student or it could also be a normal user, and I need to do the calculation of volume of a cone. So I have my information, I have my radius, I have my 8 here. So I've already entered that just to not bore that. So I've defined those two variables. But for I don't know which reason, I forgot the formula. So what you can do is simply go in the AI Formula Assistant and ask him simply, what is the volume of a cone? So volume of a cone. And then click enter or hit search. When you do that, so you see that like by default, the assistant is going to return what seems to be the most accurate result for him. So which is the volume of a cone general formula. But you can see that this is a menu that I can select other type of formula. So if I explore a bit more the other result, I can see that I have other type of formula based on my query, but on using different type of parameters. So let's say if I had only the diameter, this is the formula. So I can explore a bit. Once I've selected the formula that I want, which is great, what is great with this assistant is I can also see actually what is the definition of each parameter. So I mean, in this case, it's simple R and H are the radius and the 8, so I can also read a bit. But instead of having, so let's say you before, let's say Maple 2024, the way you would have done it is go in a browser, look for the formula, then copy paste, then convert it into a Maple language, so 2D math, 1D math, Maple input. But what we've done is we've made the life of our user as easy as possible. So once you've selected the formula you want to use, all you have to do is to click on Insert Formula. And what the AI Assistant Formula is going to process what the intelligent artificial returned into Maple language and insert it into your worksheet. And as you can see, this is executable math, so I can just reuse it. So by chance, I define my variable using the same notation, so R and H. So now all I have to do is simply to execute my volume, and I get actually my result. And all of that in few clicks. I mean, I had to type. Another example also that I wanted to show you, which is a bit more, not complex, but need more for several keywords, is this example where we want to calculate the total resistance of 5 resistors connected in parallel. And the great thing about this formula assistant is instead, you don't have to type only one word or one sentence. You can type several keywords and separate them by a comma. So instead of having to type the entire sentence, I type total resistance, comma, and I entered 5 resistors because this is what I have, then comma, and connected in parallel. And then I hit enter, so search. And here, as you can see, automatically it's going to return me actually this equation. So once again, I can explore a bit more here if I want like other type of formula, but automatically I can understand that this is the one that I want. And I can simply insert it here by clicking insert formula in my Maple worksheet. And as I've defined already my R1, 2, 3, all I have to do is to execute it. And I have my total resistance. So this was one of the new feature components that we've incorporated within Maple to allow user to ask different type of formula, mathematical formula, to to AI technology. The other interface is more, I would say, for people who like to enter code, Maple code. So behind actually this AI formula assistant, there is an entire package called the natural language package that offers a bit more actually than what the AI assistant formula offers, because it allows, of course, to return a formula the way the assistant does it, but you can do a bit more than that. So I've prepared some examples just to show you about the extent of the natural language package and its command. So first of all, of course, I'm going to load the package. And once again, I've selected 4 different exercises to show you. So let's say I'm in a physics class and I get like this equation and I'm a student and I don't remember actually what this equation represents. You can use the natural language package and one of its commands that is called the explain command. So I'm going to just open the bracket and enter my equation. So 2D math, I'm going to ask the AI to return and to explain me what is this. So I can click, and here I get the definition that is written by the AI, simply to explain what is this equation. But what is great about this natural language package and the explain command is we went, as per usual, one step above. So let's say the student didn't find exactly what he wanted, and he wanted maybe a bit more explanation. Nothing stops him actually to ask more. So you can simply reuse the explain command and ask more. So explain more about the previous concept. And now you can see that you get, of course, like a definition, but going into more depth about like each of the parameter of the equation. So this is one of the command, explain command in the natural language package. Another command that is really useful for the user who are starting to use Maple, would like to be a bit more comfortable with command how to talk to Maple, the Maple language. So as you know, there are many different ways actually to get familiar with that, whether it's like going through our tutorial, using the context panel and other, but they can user can also now use the natural language package and ask to the AI to return a Maple command. So in this exercise, we need to generate the contour plot of sinus of xy. And the command that I'm going to use is a new command that is called get command that is included in the natural language package. And then I'm going to ask the AI what I want to do. So in this case, I'm just going to ask him, how do you plot sinus of x, y? And I'm going to add contour plot because this is what I want. I'm going to see, oh, sorry. I forgot this, I always do that. And then what the get command is going to return me is simply the Maple syntax to plot my contour plot. So if I copy paste the output, I get it, I execute it, and I have my contour plot. So this is a great way actually to have access to some command in Maple, just in case you don't know how to do a specific operation in Maple. Another great thing about the natural language package is it can do exactly what the formula system was doing. So returning some mathematical equation in the form of Maple language. So in this case, we need the equation of the energy stored in a flywheel. So I'm going to use another command that is called the getMath command. So I'm going to ask once again my question. So what is energy stored in a flywheel? And then I execute it. And what I'm gonna get is a oh, did I execute it? Yeah, got it. What I'm gonna get is basically my mathematical expression of my energy just here. So exactly like the formula stand did it, that I can reuse, copy paste, and manipulate it. Last little point that I wanted to make about this natural language package, especially for the user who wants to explore a bit more and go in more depth about like AI technology, we left the possibility to the user to basically get raw query from the AI language. There is a command that is called, I'm sorry for my pronunciation, I'm French, so it's a bit hard to pronounce it, but it's called the raw query command. So basically, this command is gonna call actually, it's a way for Maple to interface OpenAI ChatGPT-4 or ChatGPT model. But unlike all the previous commands, so the explain, the get command, and the getMath command, there is no rearrangement of the result that you're gonna get. So basically, what you're gonna get is simply a raw query with no pre or post processing. So let's say I just want to see what ChatGPT is gonna return for a specific query. So in this case, is what is the methodology for extreme value? I'm gonna ask him. So how do I do extreme value analysis? Question mark, and then I'm gonna choose the model that I want. So I have the choice between choosing ChatGPT, GPT-4, GPT-3. And this is where actually the value of this command is coming from, because let's say I choose the AI model, the language ChatGPT-4, you will see that the result that I will get is not going to be satisfying to me. So it's just evaluating, takes a bit of time. Okay. So this, I mean, just as a quick note while Maple is processing that, it depends a lot on your internet connection. So if, like me, you don't have a good internet connection, it may be a bit slow. So here you can see that the query is too complicated if I use the model GPT-4. So what I can do is go back and select another model. So let's say I want to select, I'm going to select ChatGPT and see what ChatGPT would return me in this case. And you can see that in this case, ChatGPT has an answer to the model. So by playing a bit with the type of model and your raw query, you can get your result. All right. So this was my part on Maple and AI. Now let's move to the improvement, the new feature in terms of visualization and interface in Maple 2024. Can I zoom a bit? So the first feature that I'd like to talk to, and this is actually my favorite feature in Maple 2024, is the automatic argument completion. So what automatic argument completion is, it's a feature that completes command completion as well as symbol completion in Maple. So this will help any user who would like to do programming in Maple, so type in commands and enter like the specific argument in a command, because of course you can go back and forth in the help page to see which argument you need to enter first and then after, but it's not, let's say, user-friendly. So it's always like better to have it. So let me show you a bit what we've done to make basically your life easier. So here, I'd like to generate a 3D plot using this expression. So this comes really handy, especially for the student who are learning to code with Maple. So what I'm gonna do, I'm just gonna start to define my function or command. So I'm gonna call it plot 3D simply, and just copy paste this expression, this mathematical expression. I'm defining it. And now I'm gonna go and try to find the syntax of the command that I need to enter. So I'm gonna start to type plot, and you see that I have my yellow square, which is command completion that just came up. So I'm gonna hit escape, and then I'm just gonna come and select a plot to 3D because I want a 3D plot. Here it is. And I'm gonna start to work out. So as soon as I open the bracket, you see that I have the pop-up menu from automatic argument completion that is gonna open. And this is really handy because it gives the user the opportunity to first see what it has to enter straight away after the first bracket. So in this case, it's either a function, an expression, a parametric surface expression, a list also, function and list. But we didn't only do that to provide example to the user. We also wanted to make it like user-friendly. So you can see that if I go into expression, the example is my plot3D variable that I defined just previously, because argument completion is going to go and look within your worksheet which expression would work out pretty well with this command. And all I have to do is to select it, hit tab, and then I continue. As soon as I hit a comma, make a comment, sorry, I'm gonna have the next argument that I have to enter. So either I define my X range or Y range, but in this case, I'm gonna trust Maple plotting tool that is pretty clever to select the correct, the best actually range. But I can also go and select any other type of option to customize my plot. So in this case, I'm gonna select frame axis. I can also play with the color. So let's say I want a specific color scheme. So if I take this one and I take magma, so I could play indefinitely. I'm sure you understood, especially with the plot command. But once I've finished, I just close the bucket, I execute it, and I get my plot. So step by step like that, just by entering the command, I get my pop-up menu that helped me to build my command. This is another example that is a bit more complex, especially for new user. So I need to generate a directed graph with 5 vertices. So I know that I'm gonna have to use the graph theory package in this. So you see that once again, I have my command completion functionality that is gonna start. So let's have a complete graph. In my case, I want 5 vertices. And I want, once again, you see that as soon as I enter a comma, I get the option, the argument that comes next that I can select. So in my case, I only want a direct graph, and I'm gonna stop here. I want it true, so I'm not gonna do that. And then once I've done that, I'm gonna come and draw my graph. So once again, I'm gonna call graph theory, and I'm gonna use the draw graph command within the graph theory package. Execute. And once again, as previously, as soon as I open the bracket, argument completion is going to look within my Maple worksheet if there is a variable that works out pretty well with this command. So in this case, I define G, and it sees that G is the best option. So I can enter it by simply doing tab. And then I can once again play with the option, whatever I want, the layout of the label, the style, and everything. So in this case, I'm just gonna change like the label style and make it inside, and then I execute, and I have my graph. It's evaluating. Oops, sorry, it's a bit slow. I think it's because I have, here it is. Other example, because I'm sure some of you are wondering, okay, this is nice for plotting, but can I use command completion to do some calculation? Of course, yeah, command completion is applicable to most of the command in Maple. So in this case, I need to solve a differential equation. So I'm just gonna do it quickly and define my system. So this is all, and then I'm gonna import this. And then I'm gonna get my command. So I'm gonna use once again the desolve command. So if I start to type desolve, I have argument completion is gonna come. So I can explore, of course, the option that I have here. I could use argument completion, command completion, but in this case, I don't want to. And once again, argument completion, differential equation. The first option is gonna try to look. I didn't execute it properly. Sorry, my bad. Oh, sorry, there is a little glitch. I'm not sure why exactly. Yeah, here it is. suggest me the system that I've defined previously, and then I can play around with all the arguments available within the dissolve command. So let's say in this case, I want a numerical solution. And then because the exercise specifies the method, I'm going to specify which method I want to use, which is method R5. I can also select the output that I want. So in my case, I'm going to want a list of procedures and then close it. And then now I can check my solution. So let's say my solution for 0 is this, solve for 1 is this, and I got it. So I'm aware of the timing also, so I'm gonna let people play a bit with this functionality, but this is just one last example to show actually that we can also use argument completion when it comes to manipulating matrices and vectors. So here I need to solve a system, so I'm defining my matrix and my vector, and I'm gonna call the linear algebra package. So linear algebra. And I'm going to use the linear solve command that is in this package. So linear solve tab. And once again, I open my bracket and you see that the first argument, because I need to enter a matrix, is going to be P because I've defined it just previously. And then I can continue and enter the rest of my argument. So I can select the method, the data type and how I want it. So I'm just going to select a simple method just to show you because this is the purpose of the exercise. And I got my command enter in this way. All right. So next functionality when it comes to visualization within Maple. So as I hope you've seen in Maple 2023, we've introduced color bar for density plot and contour plot. And what we've been doing in this release is, first of all, improving this functionality for those two type of plots. So now you can customize, actually, you have many type of options to customize your color bar. So if you want to change the font, the label, the size, or anything of your color bar, you have a wide range of options to do it. So now you can see that I've changed it because I didn't want the default in the color bar. Another great improvement that we've been doing with the color bar feature in Maple is it is now available for a lot of other type of plot. So you have by default color bar generated for matrix plot, surface data plot, complex plot, 3D plot complex, and also some of the plot in the signal processing package. So this is an example of complex 3D plot. So you see that at no point I enter the option of color bar, but automatically, I have an issue. I'm not sure what's happening. Oh, sorry, I have an issue. I'm not sure what's going on with this example, but I should have got my property. I did something wrong. Okay, let's go to the next example. Sorry for that. Let's go to the matrix plot. Sorry, I'm not sure why I get this. Sorry, this is just to prove that I was live. This is just an error that comes from me. It's probably a syntax error that I will correct later on, but you should have got the proper result. And then in addition, now you can also have color bar with 3D plot, which means that now when you build a 3D plot, you have the option to insert your color bar. So we didn't do it by default because not all 3D plot, not all users want a color bar by default. So you can have it by simply using an option. So you can see that here I have my 3D plot. I use the color bar option. So I customized it the way I want it, and I can now generate it. Next, a nice improvement is the way you can now manipulate large matrices. So in the past, by default, Maple only displayed 10 by 10 matrices, and all the rest was hidden. But we got a lot of requests from users who are manipulating wide and large matrices because they wanted to see the data and explore those matrices. So now you can see that if I generate a large matrices, so first of all, by default, I can see actually a larger amount of data. But you see that when I put my mouse on the matrix, I can explore, actually, I can scroll over my data and look actually at all of them. While in the past, I had to open the matrix explore menu, which was not really user-friendly. And in the same way, I can also play with the size that is displayed. So let's say I have a bigger matrix. If I generate a 50 by 50 matrix, So you see that by default, this is the way it's done in Maple. You are not only going to see a 10 by 10 data, but you can play with it in order to display more of them. So you see that if I put my mouse in the corner, so let me just get it, sorry. Oh. Sorry, it's a bit sensitive. Oh. I can extend actually the size of my matrices to be displayed actually in my worksheet the way I want, which is once again quite great when you're handling large matrices. Next improvement is the improvement we've done with piecewise plot and discontinuities. So in previous version of Maple, so mainly Maple 2023 and before, when you didn't use the option discontinuity true, you didn't basically Maple didn't return it properly. So this is the type of plot that you used to have. To get the proper plot with the discontinuity, you had to use the option discontinuity true, as you can see here. And now in Maple 2024, so you see that I have the same piecewise function, and I don't have to enter the option discontinuity true, because Maple automatically is going to think about it and display any discontinuity that makes sense in the command. So that way the user doesn't have to think about entering the option. So this is another example. So you can see that here in this piecewise function, we have actually a lot of discontinuity that were not displayed properly in Maple, but now by default, Maple is going to display them in order to get the proper plot. We went also one step above when it comes to handling piecewise function, when it comes to displaying the range that makes sense. So in the past, if you were not displaying the range that you want to see, for which you want to see your plot, so your data, so you see that Maple just pick up a default range that is a 10 by 10, 0 by 10 and 0 by 100, which doesn't really make sense when we think about the type of plot. But now in Maple 2024, we've improved that for a lot of piecewise plot. So you see that if I don't define a range for this plot, Maple is going to think about like displaying all the most interactive feature of the plot. So in our case, the discontinuity, and also the fact that the plot is decreasing before 0, which is quite handy when we think about it. So this is once again another example where in the past Maple didn't show you actually the proper range. So it was minus 10, 10, and now you get actually the range in which some discontinuity are displayed. Okay, I hope that everybody is still following. Let us know also in the chat if you like those new improvements, those new features, and if you are looking forward to test them. I'm now going to switch to the part of advancement and performance in Maple, so what we've been doing for this release. So I'm going to zoom a bit. So an improvement, a great actually improvement in Maple 2024 is actually the massive improvement we've done to root finding isolate. So in the past, the solver in Maple was returning only real value. So let's say you had this multivariate polynomial system using the isolate root finding software, command, was returning you an error because basically, if I use the complex option, Maple is not going to find them. But now in Maple 2024, we wrote the algorithm to make sure that the root finding isolate command return both the real and the complex result. So let me show you the difference of result, what you are missing basically if you didn't upgrade to 2024. So this is my multivariate polynomial system. This is actually Maple 2023. When I ask for any complex roots, it's gonna tell me, no, I'm sorry, I cannot return it. And this is what I get in 2024 when I, executed. I need to re-execute this. Oh. So now I get all my complex roots returned by the command, the root finding command, which is a massive improvement. When you think about solving actually multivariate polynomial system, it's quite, I would say, consequent what you are missing with that using actually the new complex solver in Maple. Another improvement when it comes to mathematics, so this is an improvement actually. I'm sure that our long-term users are familiar with that, is the improvement we are making to simplify. Because when it comes to handling symbolically or numerically, actually, some expression, a lot of people are not happy, by the way, actually, the output is returned, or by the simplification method or others. So we always update actually the algorithm behind the simplify command to make sure that the result that is returned is the most, I would say, natural, or the way the user would want it. So a few examples. First of all, the way Maple handle trigonometric function now. We've included actually a lot of nice algorithm behind the simplify command to make sure that it return both the hyperbolic trigonometric function and return the expression in a simplified way. So this is the way this simplification, this expression was written in previous version. So you can see that there is no simplification simply. But now in Maple 2024, we get actually the proper cosinus trigonometric function in here. Similarly for this expression, so in the past version, Maple was not simplifying it, just returning it the way it is. While now, actually, you can simplify it and get the result that you need. This is a last example when it comes to trigonometric function handling it. You see how more simplified and compact the expression is. Then another improvement that we've made to the simplify command within the last version of Maple is how simplify and the combine command are now better at recognizing two piecewise branch value and merge those two piecewise branch. So I take this example of this piecewise function with two branches. Now in Maple, if I use the simplify and combine command, for the same expression, having the same assuming condition, you can see, that I get actually a merge branch, which was not the case before. Similarly, when we have multiple piecewise function, now Maple can merge them in one. So in the past, you can see that you have two piecewise here that were not simplified or merged together. While now in Maple 2024, when you simplify and combine together, Maple merge actually those two piecewise function together, which is quite great for handling a J expression. Another nice improvement is the way actually a radical were simplified within Maple. So this is actually a quite complex radical expression that was not simplified in previous version of Maple, while now if you execute it in 2024, it's totally simplified. So we've really improved the algorithm to make sure that those type of expression can be simplified the way they should be. Another also a great improvement that we've done is how Maple now include better normalization for the minimum and maximum expression. So this is an expression that was executed with a previous version of Maple, while now when I execute it, you can see that I'm gonna get a simplified version with the minimum version. Next, for advanced math and performance is the inclusion of two new packages in Maple. Those two new packages are what we call the Matroid and Hypergraph package. So just before I start, I'm not an expert in this area, but I'm sure that if we have experts in this topic in the room, they're gonna be excited. But I'm just gonna try to give you a little a summary of what it is and what this package is doing. So a Matroid is basically an abstract mathematical object which encodes the notion of independence. So it's used actually in a lot of different applications, going from graph theory, linear algebra, geometry, topology, network theory, and honestly, much more that I cannot remember by heart. So as you can see, I mean, once again, if you go a bit around and read some peer review paper in the mathematical world, you can see that this is really a trending area and this is really a hot topic. So as of now, in Maple, you can basically construct Matroid using the Matroid package from a matrix. So the way it is, so of course, I'm gonna load the Matroid, what is my mouse? I'm gonna load the Matroid package. Then I'm gonna build my matrix simply. And by simply using the Matroid command in the package, I'm gonna build my Matroid. And now basically I constructed my Matroid, which is a linear actually Matroid. But once you get this Matroid, using the package, the command that is in the package, you can do actually a lot of different operations. So you can ask Maple in the command like, which subset of column are linear independent. So I use the independent set command. So Maple is going to look within this matroid which subset is linear. I can also ask Maple which subset is linearly dependent in my matroid. So using the dependent set command. And finally, I can ask actually to Maple what are the bases for the column space of A using the basis command in here, which I get it actually as a return. Then, just as you know, I won't go into a lot of detail, but you can change actually those answers if the column vector are considered over an over a finite field, which is the field of 2 elements. So if I modify it with 2 elements, and I check actually bases, you can see that now I'm gonna get actually a different type of base. So following actually, linked to this matroid package, we also introduced a new package called the hypergraph package within Maple. So basically this package is the backbone of the matroid package. For those of you, once again, I'm trying to give a summary, but I'm sure that if you start to read about like hypergraph and matroid, we could like probably read about it and talk about it for days. But just as you know, a hypergraph is a pair of vector consisting of a finite set of V called vertices and a collection of E, so center, of a subset of V called hyperedge. So hypergraph, as indicated actually in its name, it's a generalized graph. So a graph can be considered as a hypergraph when there is hyperedge with at least a size of 2, basically. So let me show you a bit more about hypergraph instead of talking about it. If I load the hypergraph package, here I'm gonna build actually my hypergraph using the command here and define it. So if I draw it, here it is. So this is my hypergraph, with my 4 vertices that you can see here, and my 3 hyperedge are basically here. What is great actually with the hypergraph package in Maple is that it's not only displaying basically the hypergraph in here, is everything that is going behind, because this requires a lot of like complex algorithm and solving things in here. So basically, as you can see here, I just wanted to show you a bit how the power behind actually this graph by just show you some example of hypergraph generated in Maple. So I'm gonna generate a big one with 10 vertices and 100 hyperedge. It takes only a few seconds to do it, but just so you know, this requires a lot of calculation here. And we've also included actually different specific type of hypergraph. So I won't go into trying to pronounce those once again, because of my French accent, you may not understand it. But I just wanted to give you a bit of a taste of what it is. And I have a little question. I don't know if everybody wants to participate, but I just wanted to ask, according to you, how many edges do you think we have in this hypergraph? Because I think it could be quite interesting actually to know the number. So I'm gonna let you just guess it for a few seconds, but just in case, I'm gonna show you the answer, which is 206. All right, so let's go to the last part of our webinar, which is the improvement and new feature when it comes to teaching and learning in Maple. So I'm going to start by talking about a little bit about the step-by-step solution. So the step-by-step solution in Maple are actually a feature that is really widely used in education, teaching. So it's used by students going from high school to students going to, master degree, because this functionality is really great at showing a student how to solve a mathematical problem step-by-step, the same way a teacher would teach it. And what we've been doing over the years is to improve actually the type of problem included in those step-by-step solutions. So this year, we've allowed the user, the teacher, and the student to solve partial fraction decomposition problem step-by-step by simply using the partial fraction step command. So all I have to do is to load the student package, basic, and then I use the partial fraction step command and enter actually the problem that I want to solve. And for those of you, once again, who are not familiar with the step-by-step command, I just want to give a little reminder of like, it's not just like a computer saying, I've applied the rule X, I've applied the rule. No, it's really explaining to the student how to handle the expression, which rule to apply, and what they get at the end. Another improvement that we've done also is an improvement to the solve steps command, because we got a lot of feedback from teachers saying that they didn't like the way actually the solve step command was handling a logarithmic expression. So we've worked on it to make sure that it coincides with the way the teacher is basically teaching it. So if you solve this equation that contain two different logarithms, you can see that the steps, we've improved them and also went into way more detail to make sure that the students really understand it. I won't go once again into detail about all of them, but just to give you a bit of a taste of like the power of those step-by-step commands and how they can allow the student to really be independent and solve a problem and understand basically each of the steps with the rule, the reminder of the rule of the expression. And then just to finish on the step-by-step, we've also now improved the solve step also command when it comes to handling absolute value within Maple. So here I have like an equation with absolute value, and you can see that once again, we've worked on making sure that we explain everything properly to the student. And a great also little improvement that to add on that we've done to this solve step functionality is to add a visual aspect at the end. So that way, of course, the student can have the numerical solution in here, but he can also, which is great when it comes to absolute value, visualize the result. Next improvement we've done to Maple is the new improvement we've done to the check my work functionality. So once again, if you're not familiar with the check my work functionality, I would really encourage you to go and have a look at the solve practice, solve feedback command in Maple. Basically, what we've been doing actually in this release of Maple is once again widen the range of problem that can be handled by this type of feature. So in 2024, you can now use those check my work functionality to solve factoring problem as well as simplification, because this is something that came back a lot of time from teacher saying that some students they struggle with simplifying some expression, and it's not only like student at high school level, it can also be at higher level. And finally, we've also included the use of limits. So I'm aware of the time, and I'm also aware of the fact that not all of you wants to see me solving a problem, but I still want to show you a bit of an example. So if I use this product, so I want to practice factoring, I'm gonna load basically my exercise, and you can see that here I have, so basically factor, I have my exercise, and I need to go step by step exactly like the way a student would do it on his notebook, or even if he would go on a whiteboard with a teacher. So I'm gonna go basically step by step and solve this problem. And if I do x 2 minus 4, it should be this, then other math box, then next step should be 2x. Oh, sorry. Then I have x minus 2 multiplied by x plus 2. So I'm gonna make a mistake here on purpose, just to show you actually how the functionality is working. So let's say I've made a mistake and I forgot these two. Okay, I've entered all my steps, and I think that I've factorized my expression. Now I need to simply click on the check my work button, and Maple is gonna come and check actually each of the steps. And you can see that here I got it right, so I don't have anything to do. If I come and do a mistake, so I'm gonna take another problem, which is a simplification problem. So same thing, Maple is gonna load my practice little working exercise, and I'm gonna start to solve my problem. So x3, so I need to simplify in this case. So let's make sure that I do cosines of x, 1 minus cos x squared. And I close it. Once again, I enter a new math box. In this one, I should have, I'm just gonna copy just for time purposes, x squared and cos x minus cos x of 3. I'm just making sure that I'm not making any mistake when I do that. And then I enter new math, so it should be cosinus of x. But I'm gonna make, once again, I'm gonna try to make a mistake and see what Maple is gonna return. Now I'm gonna check my work, and you see that like I got these steps okay, but then I've made a mistake at these steps. And so Maple is gonna point me in here and say, check these steps. Of course, the next one is gonna be wrong. So I can come, I can see that I've made a sign mistake. So I can click again on check my work. Okay, but I still have this one that is wrong. So I can, I can go step by step and solve my problem and correct. Yeah, exactly. I got it. So this is, once again, the improvement we've made within Maple 2024 is to include actually the factor practice, simplification practice, and limit practice also within this range of problem to solve. Now I just want to finish the webinar by presenting two little add-ons that we've been doing in 2024, which is to complete actually our Math app gallery. And to be honest, I wanted to talk about it just to remind once again everybody the fact that within Maple, if you go within the tool menu, you have what we call Math app, which is an entire gallery of Math app. And Math app can be used by students, but also by any type of user to explore a specific concept, understand actually something specific. So if I take the coding section Math app, you can see that here I can visualize a specific section in here. And within Maple 2024, we've included two new Math apps. And the first one actually is one of my favorite because this is something that is quite difficult for the student to understand if they don't visualize it, which is tangent plane in mathematics. So this Math app allows the user to select a specific function. So I'm going to take this function, and then it can select the point to which the tangent plane is going to be drawn. So you can see that it can select the x, the y, and it can then visualize actually where the plan is going. The second tangent new Math app is the golden angle Math app. So once again, I'm not gonna go into detail about the concept behind the golden angle, but actually I would highly encourage anyone in this webinar to read about it because it's quite interesting, especially for those of you who really like mathematics. But just wanted to show actually how powerful this Math app, because you can then in here select the number of points and then animate and see actually how the graph is built depending on the number of points that you've selected. You can, of course, go above 100 points. For those of you who really like explain math, I'm just going to stop the animation. So let's say I want to do 250. It's going to take a bit more time, but it's going to do it. Here it is. Okay, so I think that I've covered everything that I wanted to cover for this webinar. As I said, this is not everything that we've included in Maple 2024. If you go through the extend list of what's new in Maple 2024, please don't hesitate to go in the help menu and then click on what's new. And here you're gonna have the entire list of what has been done in Maple 2024. Once again, going from user interface, education, visualization, programming, if you'd like to see the improvement that we've been doing in this area. And for those of you who are a bit more familiar with Maple and just want to do a bigger screen of the new command and package we've included in 2024, here is the list. So don't hesitate to go once again in the help and what's new menu to have a look at those.